Today I have the pleasure to introduce Debbie D'Angelo, who got her master's degree in 2012 at Columbia University in Biostats. She is now working as a senior research biostatistician at Division of Biostatistics and Epidemiology at Weill Cornell. And also she's the instructor of one of our best-rated classes called Research Data Coordination Principles and Practices. Thank you so much, Debbie. And please fill out the surveys at the back of the handouts and put them in the boxes on your way out. And remember that all the lectures materials, PDF, and videos are also posted on our website. So if you just Google BERD, Biostats, you'll pretty much get to it.
Thank you, Cody, for the introduction. And thank you all for being here. Cody had mentioned to me that there were some requests for a talk on data management. So the outline for my talk, I'll give you an introduction, a little bit about data management, and then the two things that kind of come up very commonly when people are asking about data management for their research projects are how they're going to store the data and how they're going to keep their data secure. And particularly in our context, being on medical campus, we think about HIPAA a lot and how our data collection and storage will comply with HIPAA. And then at the end, I'll give a brief summary of some resources for data management here on campus, some websites that you can refer to, and also information about the data management consulting service in the Biostatistics department. So just to tell you a little bit about me, as Cody mentioned, I'm the instructor for a data management course in the Biostatistics department. Some of my current and former students are here, so nice to see you guys. So in that class was actually developed by a professor before me after she was a data management consultant in biostatistics. And from working with researchers, she saw that there was such a need not only for the data management support, but just for education about data management best practices with researchers, because she was very frequently coming across researchers who had these really big data disasters that would be preventable with the right planning and using the right tools. So she developed this course, and I eventually took it over, and in that class we learned how to build research databases, mostly using Microsoft Access and a little bit of MySQL. And then we learned how to query databases using the SQL programming language. While I was getting my master's here, I was working as a data manager. I took the class that I teach while I was studying, and that kind of really helped me develop my skills. And so I built some research databases at Cornell the first time I worked there. I built some databases for clinical trials and the observational studies that were being done there. And then after I got into my biostats career, one of the jobs that I was working at had a pretty big data management component where we did a lot with a SQL Server database. And so there were a lot of things that I had to build and query, and a lot of reporting systems that I built actually with the help of one of my former students sitting here for that database. But also, I am a biostatistician, and I feel like half of my work is just dealing with messy data sets. So I have that perspective of kind of the end user, and I think a lot about how a lot of data sets would benefit, and I would benefit from having better data management before the data got to analysis. So back in the beginning of November, there was actually an email that went out about research data at Columbia, and there's a website about it now, this really nice research data website. And to define data management, this is what they say about it. Data management describes the actions taken during the different stages of the data life cycle, which define how data are collected, stored, secured, and disseminated. And data management best practices are defined by discipline, PI, or project. So in this talk today, we'll focus mostly on data storage and data security. There's a lot of variation on how you'll collect data, and there are a lot of ways that data get disseminated. So we'll focus mainly on talking about tools for storage and tips for data security. So why is it so important in research? Well, data is expensive to collect. If you think about all the grant money that you receive to acquire data, it's often in the thousands, 10,000s, hundreds of thousands of dollars to be able to acquire data to answer a particular research question. So, and also it can take many years of your time to collect that. So if it's not collected properly and you can't use it at the end, that would be a really terrible and kind of heartbreaking waste of resources. You may have heard of the garbage in, garbage out principle. We want to plan ahead for data management so that we're getting good data in, and then when we analyze, we're getting good results out. If we don't collect things properly, then we might not even have the information that we need to answer research questions at the end. And also, increasingly important is having some kind of a plan for sharing your data once you publish. A lot of journals now are requiring that you share data once it's requested in order to publish in their journal. So you need to have a plan in place to make sure that you can get that data together in whatever format that you need and be able to share it as needed. So in short, you want to handle your data with care. So to talk about data storage, in thinking about the tools that we use for data storage, really good tools will keep your data as clean as possible from when you're collecting it and entering it all the way to analysis and even dissemination. A good tool can prevent a bad value from being entered into your database. If it's not within the range of values that can be collected, it won't even be stored. So later on, when you go to analyze your data, you won't have to worry about doing so much data cleaning and looking for bad values. You can require that fields are collected so that you don't have so much missing data at the end. So a really good tool is going to keep your data really clean for as much of the process as possible. And one thing to keep in mind, there are a number of tools, and we'll talk about a few of the most common ones. Different tools have increasing complexity and more capabilities for for different features and keeping your data clean. As the tools get more sophisticated, it's going to take more time and probably a higher cost to implement those. So you'll need to think about a balance of what you need for your study and how much resources you have available to implement the different tools. So the tools that come up most common when people are talking about research data management tend to be Excel, REDCap, and databases. And for those of my students who are here, they would tell you that I would never give up an opportunity to talk about Excel and warn of the dangers of it. So we're going to talk a little bit about that and kind of the pros and cons of each of these tools. Then there are some other tools that do come up a little less frequently, but they do have their place in some research studies, such as survey tools and electronic data capture systems that are really specific to clinical trials. But the first three tend to be the ones that come up over and over again in a research data management setting. So Excel. So I don't think there's anybody in here who hasn't, if you've worked on a research study, you've probably received a data set that was in Excel. It's ubiquitous. Everybody has it on their computer, and it just seems like the logical tool to use. It's got this nice grid. You think you should just put your data in there. but it's one of the worst tools you could use to store your data. There was a talk given last week by the data management consultant from the Biostatistics group, and he said that Excel is about as good as paper for storing your data. You'll see there are a lot of issues that can come up. Excel gives you the illusion of being a good tool, mostly because that grid is there. There are really a lot of issues that can come up, and some of them, they come up even without warning. So you may lose data without having any warning over it. So a couple of the issues, there are row and column limits when you open a file in Excel. Excel makes assumptions about the data that you're entering, and it may change a value and how it's stored without ever telling you. And if you don't catch it right away, then that could be left there in your data set. Excel has a different default way of storing dates in the Mac version of Excel versus the Windows version of Excel. I've had issues with that when collaborating with teams that are primarily Mac users, and I'm primarily a Windows user. You may have had the experience where your data gets misaligned. You do a sort, or you delete a cell, and then everything shifts in a way that kind of shuffles up your data. And again, if you don't catch these things right away, you may have scrambled data and you don't notice it. And you would never want to get to the point where you're analyzing data that is misaligned. There's limited functionality to do data validation or logic checking. So like I mentioned before, a good tool can kick out improper values from your database. Excel has a little bit of that functionality, but it's not that great. And it's not great also at comparing values against other columns in your data set. Storing repeated measures can be messy, and version control can be difficult. So I'm going to show you examples of what all these problems look like. So the row and column limits issue. So from Excel 2007 and later, you can store up to 16,384 columns and 1,048,576 rows. Now, in our age where big data is getting more and more common, it's really not uncommon to have data sets with millions of rows that we look at. So I actually, I went just to data.gov, I believe it was, to see if I could find a data set that had more than 1,048,000 rows. And I found one. On the next slide, you can see where it was. It's the state drug utilization data. I downloaded the CSV file and went to open it in Excel. So here's the end of my Excel file, 1,048,576 rows. Now, if I hadn't known that, because it's kind of a weird number, these are all base 2 numbers, so unless you have an incredible ability to recognize numbers in base 2, you might not realize that that's not where the end of the file should be. So I did it again. I took the same CSV file. I opened it in Access, and I opened it in SAS. And you can see in both of these that this file actually had 2,343,727 rows. Now, luckily, in the newer versions of Excel, and I don't think this was the case in the older versions, it does give you a warning when your data get truncated. So it tells you file not loaded completely, and then it tells you a little bit about the storage limits. So what it suggests here is that you save the file in smaller pieces. I think that seems like a lot of work. I would say open it in a different tool. So be aware if you are opening a file that you think has a lot of records, potentially more than that 1,048,000 limit, check for that to see make sure your data don't get truncated. Okay, so Excel also makes a lot of assumptions about the data you're entering. Excel was designed as a calculation tool, not really a data storage tool. So in its mind, it's thinking that everything you enter is either a number or a date. And dates are actually stored as numbers, so it's thinking everything is a number. So there are things that it does when you enter data. It doesn't give you any warning that it's going to change. So this is just, these are just a few examples of what it does. So if you had any identifiers where you had leading zeros in a number, it just takes those away. If you work in genetics research, if you happen to be studying a gene that looks anything like a month and day combination, it's going to be turned into a date. So DEP1 is the gene for deleted esophageal cancer 1, and it's now December 1st. Once you hit enter, it changes. And I should note that once it's changed, there's no Control-Z kind of thing that you can do. You have to delete it, reformat the cell, and enter it again. There's no way to get the original data back. So you need to catch it immediately, reformat, and re-enter. And there's actually, there are actually papers in the literature talking about this issue with gene names. There was one paper, and I'd be happy to share if you're interested, that said they studied a bunch of supplemental information from genetic studies, and they found that around 20% of them had errors in the data due to this gene name conversion in Excel. Also, if you're working in any field where you need a lot of precision stored for a measurement, Excel can only store up to 15 digits of precision. I know that seems like a lot of precision. This was an issue for me once. I was working with some data where there were identifiers that concatenated a whole bunch of information together, and they wound up being 32-digit identifiers. I made the mistake of opening a CSV in Excel, and then I realized that all of my identifiers had zeros after the 15th digit. So again, it doesn't tell you it's doing that. You type in your number, hit enter, and then if you look at it again, you'll see that your precision goes away in the number. So it's not really very nice that Excel just makes all of these changes on your behalf without really knowing what you're trying to enter. So there's the dates issue. So like I just mentioned, Excel actually stores dates in the background as a number. It takes all dates and represents it as a number from a fixed point in time. So the serial number 1 in the Windows version by default represents January 1st of 1900. So if you wanted January 2nd, that's number 2. And then Excel just puts a format on it so you know what date is being referred to. Now, in Mac, the default is to start on January 2nd of 1904. Not really sure where that came from, but if you're pasting a number in or kind of merging something in between spreadsheets that are in these two different formats, you can get the wrong dates in. And this exact thing happened to me. I had a data set that I was working with, and it was on depression and premature birth. So date of birth was a big variable for us. We needed to know weeks of gestation. So there were a bunch of date of births that were missing, and the researcher said, okay, we'll get those and send them to you. So she sends me a new spreadsheet, and I merge the numbers in. I just tried to do a quick thing in Excel, merge the numbers in, and I was merging. Let's say, I wanted January 1st, but I'm actually merging in January 2nd of 1904. So I looked at all these new dates that I imported, and I was like, these don't fall in our study window. They're all about 4 years off. And this is actually before I even knew about this issue. So I did some research, I asked some colleagues, and they were like, oh yeah, there's a big discrepancy in how the dates are stored. So again, if you're not aware of this and you don't catch it right away, you can easily have the wrong values added into your data set. So I think everybody's had this experience at one point or another when you're trying to sort data or delete a value in Excel. Just a toy example. This happens primarily when there's a space between columns in the data. So by default, Excel only selects the contiguous columns of data to do the sort. So if there's a break in the data, it's going to select only what is before that break and sort that. Now, in this tiny thing, we'd probably catch that if we tried to do a sort where we want ID to be descending instead of ascending, then we could see like, oh, whoops, that looks backwards. But when you're dealing with really large files that have tons and tons of records that you can't all see at once in one screen, then you may have just broken apart your data and created misaligned values. Same thing with deleting a cell. When you do the little delete feature, the default, you get that little box that says, do you want to shift cells up, left, right, down? So if you just kind of go through that without really thinking, you could delete the cell, and now you have everything shifted off by one. Again, we could see it in this tiny example, but if you have a really big data set that you can't see all at once, you might not realize it at first. Now, in pretty much all the other tools that I know of and that we'll talk about, you can't break apart a row of data like this. So you'll never mess up a relationship, related pieces of data in this way. Data validation and logic checking. So validation, like I referred to before, is limiting the values that can actually be stored, so that later on, when you're analyzing things, you don't have values that don't make sense, like a male patient that had 3 pregnancies. So you want to, in a good tool, set your fields up when it's appropriate to block values that don't make sense. So for example, if you're doing a study that involves chart reviews and you only want the study period to be January 1st of 2015 to the end of 2017, when you enter a treatment date, if it falls outside of that range, it wouldn't be entered. But in Excel, you can do that. But the problem is that if you were to change that later, any values that no longer fall within that range, they can just stay there. It's no big deal. It lets invalid responses remain in your data set. So let's say you shorten that same study period from January 1st to June 1st of 2015. If I had any valid dates from February, March, anything up to June, it would just say, oh, okay, and just leave them there. And it doesn't tell you that it's doing that either. Whereas in a lot of other tools, you would get a warning at the very least, saying there are values in here that don't meet this rule. Either what do you want to do, or we can't save these records. So you can see there's a lot that Excel does without warning that could leave you with values that you don't want once you go to analyze your data. Now, logic checking happens when we compare different columns within our data set, or different fields, to make sure that the values make sense. So for example, if you have a treatment start date, it should come before the treatment end date. You don't want to have it reversed. Or things like any fields related to pregnancies should be null for males, because that doesn't make sense. So in a good tool, we could prevent those things from being entered, and we can check to make sure that our entries make sense by comparing different columns. Excel can do this a tiny bit. It doesn't have very robust capabilities to do this. It can do simple comparisons, like the example of treatment start date coming before the treatment end date. But if you have more complicated logic, like an if-then sort of situation, Excel can't handle that. So if you wanted to say if sex equals male, then allow the history of prostate cancer field to take the values of yes or no, but if sex is female, then we just want to leave that null. Excel can't get that fancy with checking your data. So repeated measures. I purposely put this really microscopic picture up there for you to see. When people want to store repetitions of the same type of measure. So in the class that I teach, one of the first exercises we do is to create a way to store data on pregnancies. So having multiple pregnancies per woman and allowing for the recording of multiple births per pregnancy. So when you have a lot of repetitions, people tend to just put all those repetitions in columns, and it makes things incredibly, incredibly wide. This wasn't even the whole spreadsheet. I took an actual example of something a student had designed. But think about if you're trying to query that later. If you want to see all the dates, or you want to see birth weights, what's the average birth weight per baby born per pregnancy, you then are going to have to refer to a lot of different columns in here. And plus, just entering data is very cumbersome, having to scroll all over, and then making sure you're getting into the right cell, because there's so much blank space once you get to these high repetitions. Some people recognize that the repeating columns are cumbersome, and so they'll consolidate. But then what winds up happening is that they'll store, there will be redundancy in the rows instead, which we might think, okay, well that's not so bad. At least, you know, it's not as unwieldy to work with. But whenever you have redundant information, then it's an invitation to have discrepancies between those values. And especially if you've ever done data entry in Excel and you say, oh, I just want to copy this phone number down. When you're dealing with numbers, a lot of times it will increment the number by 1 when you drag. So you might not even be copying the same thing. So when you have longitudinal or repeated measures, there are a lot of issues that could come up with having redundant or inconsistent kinds of values. And then one of my favorites, the version control problem. So I think we've all been in this situation where we update a file and then we want to resave it with a new name so that we know this is the most updated version. But then it gets to the point where all of your names are fighting for each other for, no, I'm really the last one. No, I swear. No, no, really, I mean it. This is the final version. But, you know, it's kind of hard to tell. And you have so many different changes in all the different versions, so it can kind of be a mess to keep track of. Whereas in the next tools that we're going to talk about, everything's kind of entered into one repository. We don't have these same kind of issues with having multiple files, different versions of the same thing stored. Limitations then gets into technical knowledge and cost. So in order to set one of these up, you need to have training on proper design, and it takes a lot more time and usually more money to set these up. So then other tools, survey tools get used on occasion. So things like SurveyMonkey or Qualtrics. We used to have a free subscription on campus to Qualtrics. I think that just went away at the beginning of the year. I used to use it, and this is what it looks like. These have some capability to do data validation and logic checking, not as much. And also, these are not great if you need to store any kind of sensitive information. For that, you would want to use something like REDCap or a database. And then if you're doing a clinical trial, you may need a more specialized tool for your CRFs and monitoring the study. There are tools specially made for clinical trial data capture. And you can also have a relational database built specific to your customization, what you need in your study. So there's OpenClinica, which I think is a free software. And then if you wanted a custom solution, that could be done through the Biostatistics Data Management Consulting Service. So just in general, some tips. It's good to have your data storage tool set up before you start collecting your data. When you go through the process of planning what you're going to capture and building that tool, your data kind of goes through vetting, and you make sure it's another level of making sure that you're capturing what you really want to capture. In my experience, when we've collected data before the data capture tool has been set up, we wind up having to go back and change things later because we realize, oh, we weren't really capturing what we needed to, or this isn't going to work out when we analyze it, so we wind up having to change something at the end. So it's more work. So if you can manage, and I think you usually can manage, I don't suggest using Excel as your data storage tool. And when you're choosing a tool, it's like I mentioned before, you're going to consider what you need versus the resources that you have. The more you need to close that window of error on data entry, the more sophisticated a tool you're going to need. But then it's going to come with a higher cost. So you'll need to plan for that in advance. When you're planning for funding and when you're planning to start up, this could take months to build a more sophisticated system. And always think with the end in mind when you are planning for data management, data storage. Think about how you want things captured for your analysis. Think about what kind of data sharing you're going to do. And make sure that all those things are accounted for so that your data gets stored appropriately. Okay, so then data security. So a lot of people get concerned. They want to make sure that they're storing things in a way that's HIPAA compliant. And there are a couple of key concepts in making sure you do this. So the first is to de-identify your data and encrypt your devices. So if you remove PHI from your research data and you encrypt your devices, you can take HIPAA off your mind and feel pretty confident that you're going to be compliant. And I'll get into details about how we do this. Research is very collaborative. So obviously, there are going to be situations where you want to share your data, but you need to share your data securely. We all use Dropbox and Google Drive a lot, but these are not HIPAA compliant tools, and they shouldn't be used to share your data. And don't collect information that you don't need, especially if it's sensitive. So just to touch on HIPAA, which I know we all go through training over and over on this campus, but we are part of a covered entity, so HIPAA applies to all of us. HIPAA covers the privacy and security of PHI in any medium, so it could be electronic data, paper data, spoken word. And so how do we define PHI? So it consists of two elements. It has to have medical information that is linked to uniquely identifiable information. So if those two things are together, then you have PHI. But if you don't, then you're covered. So these are identifiers that would create identifiable information. If you just do a Google search for HIPAA 18 identifiers, you can find this online. So you want to make sure that in your what in your data storage, you aren't collecting these with the rest of your research data. So how do we do this? Obviously, if you're going to be working with patients, you're probably going to need to capture some of these identifiers. You need to know who they are. Probably need to know their phone number so you could call them to come in. It's okay to store that. Just keep it separated from their research data. So any information that's identifiable should go in a separate file and stored in a separate location. All of your research data, take all of those identifiers out, put that in a separate file, that in a separate location, and then you're okay. So once you de-identify a data set, then it's no longer covered under HIPAA, and that falls under this safe harbor rule. If you want to look that up and get the details, then you are covered. So then there's the minimum necessary principle, which I referred to before. If you don't need the information, then just don't collect it and don't store it. It's not worth the risk of having it if you don't need it. So with electronic data, like I mentioned, we want to encrypt as much as possible. So encrypt files when you can. You can actually encrypt most Microsoft Office documents, Word documents, Excel, Access databases. They can all be encrypted. If you look up how to put a password on a document, that password protection is actually encryption of the file. If you're working with flash drives, mobile devices, computers, they should all be encrypted if they're storing sensitive research data. And finally, if you're sending any emails that may have PHI, you guys may know already that you can put #encrypt in the subject line of our CUMC emails, and that will send an encrypted message. When it reaches the other person, they actually have to download the information from a secure portal, so the whole thing stays encryption throughout the exchange. So like I mentioned, Dropbox and Google Drive, not HIPAA compliant. So do not use this for sharing your data, any kind of sensitive information. On our campus, we have this Data Anywhere, which is a secure alternative for data sharing. And you can contact CUIT to request access for this. And I have a link where you can find it. So to finish up for some resources, this is a website that I was referring to before. There was an email that came out, I think, to the whole campus in the beginning of November. This is a new website that has all resources and guidance about different aspects of data management, from retention, data security, storage, etc. So if you go here, you can poke around, and there's a lot of detail on all of these things. If you need help with writing a data management plan, if you're in the grant writing process and the funding body wants a data management plan, there's resources for doing that as well. There's also, this is an older site through the Scholarly Communication Program, also part of Columbia University, and I have the link there for you as well. This has some more resources on research data management. Through BERD and the Biostatistics Consulting resource, there is a data management consulting service. Has information on what it covers, options for data collection, clarification and guidance in selecting tools, evaluation of security and backup options, requirements for data sets for analysis, guidelines for moving existing data into a properly formatted and secure environment. The data management consultant is Richard Buxbaum. His information's there, and if you go to the link at the top, that has the information on the consulting service. And finally, if you want to take a more DIY kind of approach, you can come and take my class. So it's a graduate level course in Mailman in the Biostatistics department. The call number is Biostatistics BA 8180, and it's research data coordination principles and practices. We cover how to build research databases and Access, how to query databases using the SQL programming language. And I give a tiny bit on REDCap as well, if you're interested in learning that. But there are so many resources online for REDCap that they can probably do a much better job than I can in the class teaching it. So with that, I will open it up to any questions that you have. So the question is, are tools like MySQL good for images or just more for numbers and text? It's a good question. I know that in Microsoft Access, there's a capability to store images, so I would imagine MySQL is a more industrial strength database compared to Access, so I would imagine the answer is yes. I haven't done it, but I think so, and I'm sure that could find that out with a quick Google search too. The question is, what's really the issue? I mentioned that REDCap kind of wants you to know in advance how many events you're going to have for a particular field, and that it's not great at capturing unanticipated events. So what's really the issue with that? So let's say we are storing diagnoses. We want to know what comorbid diagnoses a patient has when they come to our study. Some patients might have none. Some patients might have 1 or 2. Some patients might have 10. But in advance, it's really hard to know how many the patients will have. So we might take a guess. We might say, all right, let's set it up to store up to 5 diagnoses. And then we get a patient in our study that then has 10. So now we would have to go back and sort of retool and then add more spaces for those things to be stored. So it's just a little less flexible. You can still go back and do that, but with like a relational database, you don't need to know that in advance. It's much easier to capture just as many as appear without having to create fixed places for each ones in advance. Okay, so the question is, which would you prefer, Excel or REDCap for logging your contact with patients? I would always pick anything over Excel. REDCap is also, I think it's designed to be HIPAA compliant, so I think you're much better off using a tool like REDCap. The question is, if you've already stored data in Excel, can it be converted to REDCap or a database? Yes. Yes, it can. You may need some help from somebody who knows how to transfer it at first, but it's doable.